Hello, and welcome to our session on architecting software delivery platforms. My name is Mikhail Shapirov. I'm a Senior Partner Solutions Architect here at AWS in the container space. My role is more horizontal. I work with a lot of partners in this area. But I'm also, other than the solutions architect, I used to wear hats of platform architect and enterprise architect, as well as a software engineer. In fact, originally I joined AWS as a senior SDE, so I'm a little bit familiar with how AWS is built from the inside. And today we're going to talk about how to architect software delivery platforms, taking some of my experience into account of what the best practices are for software delivery platforms in general and on AWS in particular. Quickly about our agenda, we will start with the enterprise setup. We'll talk about organizational alignment and environments and logically define what we want to build. After that, we're going to start building it, starting with day one provisioning. We need to provision our clusters, like our EKS clusters, for example. Then we're going to talk about tenant onboarding, and tenant in the context of this presentation is a tenant from the platform perspective. Those are development teams, organizational units, but they can be your actual customer tenants if you need physical workload isolation for them. Then we're going to talk about workload onboarding and move to operational strategies, how you deal with multiple accounts, multiple regions. And at the very end, we're going to discuss how you can practically take this and use it with some of the open source projects and some content that we'll share for your own benefit, whether you're a customer or a partner. So let's talk about enterprise DevOps and in general, when does this question of having a platform come into play? Nobody builds platforms just for the sake of those platforms. They don't necessarily solve specific business problem directly, but the platform is an enabler. And in general, enterprises move to those platforms at the point when they realize that traditional IT that you see on the left doesn't necessarily work, doesn't provide enough agility to software delivery. And at that point, the pendulum may swing all the way to the right, and DevOps, full DevOps, all the functions are within the development teams, may seem like a good solution, very agile, and hopefully the architecture and design of the platform will sort of emerge. But what, in my experience, what actually will emerge is can be pretty messy. So we will settle on something that is right in the middle, is the enterprise DevOps, when the infrastructure, governance, security, and compliance functions are retained by the enterprise, while developers focus on application development and value-add activities. Enterprise software delivery, that's the diagram that simplistically shows what we're actually trying to achieve. We assume that the organization is already aligned based on your agile transformation to represent the structure that you want to get. And you may think, well, why don't we just have some sort of a delivery platform or delivery framework that will push our software to all of those environments, to multiple regions, to dev, staging, and prod. What that platform will be, we're going to build together. And the failure domain, let's say we don't do this, what it means is if we kind of approximate the software delivery process to a software factory, then effectively lack of this enabler will create multiple bottlenecks in your software delivery process and overall affect agility of your enterprise. Is it a platform as a service? What is that software delivery platform? It is a PaaS in a way as far as objectives, but not so much in the traditional sense. It is interesting how the PaaS offerings evolved on the market, and some even make an argument that they didn't really gain as much popularity as one would hope they would. One of the reasons, it is a very opinionated approach, and if your opinion as a customer doesn't match the opinion of the vendor, that's where that approach doesn't work. They can be also pretty expensive. However, the basic principles remain and objectives remain, and let's see what AWS can do for you in this area, since it already manages a lot. So trying to find a good definition for a PaaS, these two lines that I have, provider manages entire platform infrastructure and you are abstracted from lower level details, seem to be the common denominator for all of them. And as we showed last year on architecting multi-tenant PaaS systems, there are the following components of each PaaS. You have an API wrapper, a workload manager, customer endpoint, deployment pipeline, which is fairly opinionated, monitoring service, and metering service. Now, API wrapper and customer endpoint are just basically abstractions that hide the underlying infrastructure from the tenant. So in our case, we're not going to talk about the API wrapper. That will be implemented by GitOps in our case. The customer endpoint, the same thing. We're not going to expose any specific customer endpoint other than the GitOps pipeline. And deployment pipeline is not going to be very opinionated when it comes to CI. It's going to be fairly opinionated when it comes to CD, which is a continuous deployment and continuous delivery combined with your CI. So there are multiple scopes that we need to address with our platform. It's a region scope, cluster scope, and tenant scope. We'll start with the region scope where, other than the global platform itself, that's the very next item on the list. And the general infrastructure doesn't go away. Someone needs to provision your VPC, create your public-private subnets, availability zones, network routing, NATing, all of those aspects still apply. You may want to have a distributed tracing solution as well in place, as well as metrics and observability. And outside of the perimeter, you may want to expose your API, so probably you're going to be dealing with API gateway, Amazon Route 53, maybe App Mesh as well, certificate manager, Elastic Container Registry. All of those components will be part of our platform. After that, after we're done with the regional scope, we're going to address the cluster scope. What's going to be running at the cluster level? So as a platform architect, I would like to ensure that we have proper cluster management first. It's provisioned using infrastructure as code. We have cluster auto scale, so we can scale the cluster up and down the way we want. Backup and recovery is handled, and storage needs are also addressed. On the observability side, we need to make sure metric server is running. It's a prerequisite for a number of monitoring solutions, as well as obviously HPA and scalability at the cluster level. Container insights, that's observability from the AWS side for containers. Distributed tracing may be represented by an X-ray daemon. On the security side, we want to make sure that there is a global network policy support. We have runtime security solution in place. We have PSP or OPA with gatekeeper policies enforcement as well. And tenancy management. How do you onboard a tenant? How do you isolate network for those tenants? How do you isolate their compute so they don't step on each other's toes, and as well as storage? Now let's move on to the tenant scope. That's the team scope, the development team or org unit. And as a developer, I really want to just build, deploy, and support my applications. So as far as build, we will use some source control. We're not going to be very opinionated. Developers can choose any Git-enabled solution, whether it's a code commit or it could be a GitHub, a Bitbucket. As well as on the CI side, as I mentioned, we're not going to be very opinionated on that side. Developers like engineers, they like to choose their own tools. They can obviously choose AWS Code Pipeline, but Tecton is also very popular lately. Circle CI, Jenkins is not going away. So all of those options are on the table. On the deployment side, while we will provide an approach for deployment, we want our dev teams to control resources that they're allowed to control. Those are deployments, Kubernetes deployments, maybe services, they want to have jobs, whatever it is, they should be able to define. They will have ingress control, expose their API somehow, and they need to have some progressive delivery tools like blue-green deployments, canaries, and things like that. And when it comes to support, I need access to logs. That may be done with CloudWatch, access to distributed tracing to gauge performance, or just general troubleshooting, as well as sometimes maybe cluster level access should also be provided as read-only. We shouldn't allow any mutations, obviously, especially in production systems. But for troubleshooting, it can be very handy. So let's start with day one provisioning, and we'll start building it. So how do we provision, let's say, EKS clusters in general? So I myself use EKS Cuddle when it's something quick. Especially, it's a great tool. You can use Bash and orchestrate AWS APIs. We can call out a number of partners in this area, like Rancher, and Nirmata, and Rafe, and HashiCorp, and Pulumi, Weaveworks. They continue to delight our customers. All of those options are on the table. But with that, we really want to settle on infrastructure as code as the current modern approach for infrastructure delivery. It's version controlled. And I really see that there is code in the name, so there has to be code. And as an engineer, I like to have compiler support, strong typing. At the same time, I recognize that the skill set that enterprises have, they do count, and you need to make decisions based on the skill set as well. So TypeScript and our CDK may be not a bad option. At the end of the day, it's a Node.js application. So we can define a stack, and we'll create a blueprint effectively. The blueprint will contain everything that we want at the cluster level, and make sure that whenever we deploy a cluster, all of those components are up and running. We can create a VPC. We can do it as easy as this. You can choose an existing VPC or use this one, and once it's with a single line of code, it will create all the availability zones, subnets, public and private, set up network routing, and all that stuff that is mandatory in the modern software systems. Then we'll create a cluster. It's as easy as just writing new EKS cluster with whatever capacity you want. You can see there is a Kubernetes version here. It's version 1.8. It also gives you an idea of what it means to upgrade that cluster later on for day 2. For instance, if I change that version to the next version and just rerun it, it will upgrade my cluster to the next version. We'll create node groups. We'll have full control depending on your instance types. It's very simplistic in this case as min 1, max 4. It can be 40. And at that point, we're going to take a look at what cluster scope and software should be running in there. We will introduce a concept of an add-on, that not to confuse with the add-ons that were announced, this reInvent managed add-ons with EKS. The number of add-ons is fairly limited right now. We will use add-on as an abstraction to wrap an ISV vendor, some software bundle that should be provisioned along with my cluster. So for example, I need CNI global network policy. VPC CNI plugin doesn't support it out of the box. In this case, we're going to choose to use a Calico network policy add-on, but it might as well be Cilium or Isolvent add-on or any other CNI from the alternate CNI list. Metric server for HPA, we'll add that add-on. Cluster autoscaler, CloudWatch Insights, Nginx ingress controller to control ingress as we discussed. Flux or Argo CD add-on, or both, can be enabled within the cluster. Normally you'll choose one or the other, and many more. Once it's done, you don't need to deal with the instantiation. The EKS blueprint will just automatically run through that list and instantiate all of those add-ons, and you will have a cluster in the state that you desire. Now, tenant onboarding. Once we have the cluster infrastructure provisioned, we need to create a namespace, set up network egress rules, and set quotas. Obviously, maybe you also want to label your namespace or create some annotations for injection of sidecars and things of that nature. And that's a very important part, service accounts and IAM rules for service accounts. We need to enable that team to communicate to infrastructural resources that they need to consume, whether it's a DynamoDB table or an S3 bucket. And let me show you how we can do it now. Just recently, it wasn't as easy as I'm showing it here. but the level of tools is just amazing lately. So we simply create a service account, and we create a bucket, and we grant read-write permissions to that service account. Now that service account is in the namespace of the target team. And in this case, the team name is Team Troy. And now Team Troy can associate their workloads with that service account and make authorized calls to the underlying infrastructure. There may be other setup as well. Let's continue with tenant onboarding. And let's say we have teams. We have at least 3 teams. There is a Team Troy, Riker, and Burnham. All of them have resources that they need, and they have some sort of a setup. We will create those teams, and that kind of tells you that you can pick and choose the teams that you want to provision in the target cluster. You can even have different profiles. Maybe Team Troy needs to run in US East 2, but doesn't need to be in US West 2. Those profiles can exist depending on your business needs, and each team will the setup for it will execute, and will have the infrastructure for those teams provisioned in the underlying namespaces that we defined, as well as resources associated with that team. Once our teams are provisioned at the cluster level with proper segregation of controls, as we showed here, that service accounts, for instance, all the security concerns are managed by the platform team. We move on to the domain when we need to provision their workloads. And for that, we're going to, in this specific case, we're going to use multi-tenant GitOps with Argo CD. It's a great tool for multi-tenancy. Flux CD as well has very similar capabilities. Argo is used because of its, maybe a little bit visually more appealing. You have UI, and it's kind of like a little bit more enterprising. So we're going to use app of apps pattern. In our case, each of those teams, like Team Troy and Team N, as shown in the diagram, has its own repository where they store their Kubernetes resources that they are responsible for. We want them to keep that responsibility. We just need a place, such an Uber app, where all of those apps are defined, so that in a single shot we can provision all of those workloads as part of cluster bootstrapping. And that's what GitOps, in this case, is going to do for us. From that Uber app of apps, each of those repositories containing those resources will have some sort of a webhook effectively into our cluster, and the GitOps engine will pull those resources and reconcile the state from the corresponding repositories to the state in the cluster, making sure the workloads are up and running. Now, bootstrapping and how exactly we're going to do it. That's how the app of apps is going to look like. We're simply going to have Kubernetes resources for each application. And as you can see on this diagram, each team has an app, and the only thing that we define in that app is a pointer to their Git repository that is owned by those teams. The platform team doesn't necessarily need to have write access to them. It's just a read access. And after it's done, we can simply bootstrap with a single command or a couple of commands if you want to have full control on at which point applications are actually synced in the target cluster. With that, let's move on to the deployment strategies, or effectively tools for progressive delivery. It's a very broad topic, and there's not much time to really cover it in details, but I wanted to highlight some research that I made on my own with respect to the tool selection that is available to you. We're going to compare Argo rollouts, Flagger, and then Service Mesh Direct and Kubernetes Direct. Now, practically, or what do we want to achieve? We want to let developers have blue-green or canary deployments, metrics-driven decisions. They need to have rollback capabilities and maybe some analysis built in. You can surely achieve it with Service Mesh and even Kubernetes Direct. For instance, App Mesh, as well as Istio, allows traffic control, and you can achieve blue-green deployment and canary as well pretty easily, but it's not fully automated, and it's nowhere near the level of convenience that you can get with Argo rollouts or Flagger. In addition, when it comes to metrics-driven decisions, that basically means at the point when we roll out our deployment, let's take a look at our monitoring system, and if the rate of failures exceeds a certain threshold, let's call it a failure or roll back. Or if that same rate of failures is very low, let's gradually increase the traffic that goes to the new version and eventually get rid of the old version. All of that is built in within those tools, and as well as the analysis itself, which may be some sort of a software and experiment that you may be running in the form of a test that's constantly running proactively, because you really don't want to wait for production traffic to hit your new deployment, because at that point it's too late. You really need to proactively test it, and running those tests continuously is enabled by Argo and Flagger. And wouldn't it be nice to just have a clear DSL where you can just say, I have a canary in my Kubernetes deployment? And that's exactly what Flagger provides. It can give you a canary resource, which is a CRD, and this you can define that the provider for that is Nginx. It can be AppMesh as well. And the metrics which we will use to assess whether deployment is successful or a failure can be CloudWatch. And Flagger integrates with CloudWatch and integrates with AppMesh, so that's why I'm kind of leaning a little bit more towards Flagger compared to Argo rollouts. However, pound for pound, they're quite similar. In addition, Argo rollouts will probably force you to modify your actual deployment, Kubernetes deployments, while Flagger is a concern that can be applied independently from your Kubernetes resources. Let's talk about now multi-cluster and multi-region and multi-account. So once we have those clusters that are configured with proper add-ons, we have proper teams, we have workloads onboarded, we can instantiate them anywhere in any accounts and in any regions at at our discretion whenever we need it. So let's say I want to just deploy a single development cluster. That's how the code is going to look like. Just define the blueprint, and whatever teams and add-ons were selected, it will instantiate it in a specific region. We can do a couple of staging clusters in US East 2 and the US West 2 as well, just as easily, with the full ecosystem that we just described. At the multi-account level, we can probably, it's a good idea to split dev, staging, and prod accounts. We could do that. Here is our stack that is a dev account in US East 2 and also a prod account in US East 2 for the same cluster. And all of that can be done just as easily as, just a few lines of code can help with that provisioning, and day two operations, since it's backed by CloudFormation and will reconcile any kind of drift whenever it happens. And at this point, let's think about what about the actual pipeline for the infrastructure as code itself, because it is clear developers will use CI, they will use GitOps, and they will push their workloads into the cluster, but we also need to have a pipeline and have clear gates how our software is rolled out, especially when it comes to any version upgrades of an add-on. You may want to move to the next version of Calico, whatever it is, and you want you want it to be done in stages. Start from dev, check out if it works all good, then move on to staging, then move on to prod. And CDK provides you self-mutating pipelines. Effectively, you can create a pipeline, and it will self-mutate itself. And within that pipeline, you can define the provisioning for as many regions and as many accounts within a single pipeline, and it will orchestrate it for you. So in this case, I will create a dev account and a staging account cluster in those accounts, and we're going to get a pipeline with clear transitions where you can have even manual approvals, let's say from dev to staging to prod, and your system is going to be fully automated. That will hopefully delight your customers, because at that point developers don't need to think and spend too much time on various concerns that deal with various failures. You have full visibility at the infrastructure level, full visibility at the development and the production health as well, and can focus on the business value. So a few words on how this system can be leveraged by our partners other than customers. It's probably clear how customers can use it. Partners, for consulting partners, we have conversations internally with large consulting partners, and all of them have something like that on their radar, or they have already an offering, and they can either use it directly or just use the patterns that were described in this session inside their platforms as well, addressing all those concerns and scopes that we talked about. And the ISVs, there is a very clear path with those add-ons how you can bundle your ISV product and make it part of a continuous delivery. When it comes to managing hundreds of clusters, it becomes a hassle to really provision each individual ISV product. If it is bundled within a platform, customers can get a solution that is fully secured, observable, reliable, etc., with all of those concerns that we talked about in a single bundle. Some of the references that I used here, we actually described an open source project that for the CDK EKS blueprint. The Argo apps example with the app of apps is also captured in GitHub. Definitely take a look at Argo CD, Flagger, and Argo rollouts. It's very interesting. Those tools are just amazing how much they can save time for development, for developers. Architecting multi-tenant PaaS offering that I referenced before, as well as an interesting article on why PaaS market failed to live up to the hype and why we actually deal with the question of creating that kind of platforms is also referenced in this list. With that, I would like to thank you for your time. I hope you found this presentation interesting, and I look forward to communicating with you, talking to you if you have more questions. I realize that we didn't really have too much time to cover such a broad area, but hopefully it gave you enough ideas to make it more or less practical for them. Thank you for your time.